All right, so we've already talked about evaluating composition of functions by an equation, by a table, by a graph. Now we're actually going to do composition of functions with equations, and no, there's no evaluating in this one, okay? So we're going to do function composition, and that is applying one function to the results of another. So we've already talked about this. It's just where you're plugging in another function into another function and you're simplifying. So we've seen it written like this, and we've also seen it written like this. So this is just a review slide to show you, to remember the two different ways that you can write composition of functions, okay? All right. So what is a composite function? A composite function is a function that depends on another function. A composite function is created when one function is substituted into another function and then you simplify, okay? For example, f of g of x is the composite function that is formed when g of x is substituted for x in f of x. So remember, we've already gone through this, but just again, so this right here is read as f of g of x. And remember that this can also be written as this. I'm mainly going to stick to this today because I feel like we've gone over the differences and how to convert between the two, okay? So here's a guided example. A composite function is created when one function is substituted into another one. So I give you two functions. Sometimes you'll be given three, but you won't do composite of three in here. You can do it just composite of two functions, but you'll have three functions. So you need to make sure you pay attention to the letters. So this is saying f of g of x. So that is saying that I'm going to take g of x, this whole equation right here, and I'm going to plug it into all of f's x's. So this is where parentheses is really important, okay? So g of x is x plus 5. So I'm really finding f of x plus 5, okay? So I'm going to substitute all of f's x's with x plus 5. And I have 3 times x plus 5 plus 2. You're going to distribute the 3, and that's where you get the 3x plus 15, and then you just bring down the 2. Combine like terms, and that gives me the 17, which is your final answer, 3x plus 17. And you can also go the other way. I can take f of x, and I can plug it into g's x's, which is this one right here. And there was nothing to distribute, so they got rid of the parentheses and combined 2 and 5, which gave them the 7, okay? Another guided example, okay? So you can pause the screen and look at it if you want to. It's going over the same thing. So let's do some examples ourselves, okay? So it says given h of x equals 4x minus 4 and f of x equals negative x plus 3, find h of f of x. So this is saying that I want to take f of x and I want to plug it into h of x. That is what that's saying. So this is saying, what is f of x? F of x is this, correct? So I'm really finding h of negative x plus 3. So I'm going to take this h function and replace every x with this equation. So I now have 4, parentheses, plug in f, negative x plus 3, and then bring down that negative 4. So all I did was replace my x's with f's equation. And now it's just back to simplifying. We're going to distribute, and I get negative 4x plus 12 minus 4. 12 minus 4 is going to be 8 because we got to combine our like terms. So it'll be negative 4x plus 8. There's nothing left to simplify, so that would be your answer. Okay? All right, next one. So this one's got 2. We're going to go both ways on this one, okay? So it says given g of x equals the square root of x and f of x equals x minus 2. First, I want to find f of g of x. So what is g of x? G of x is the square root of x. So I'm going to replace g of x with the square root of x. And I have f of the square root of x. Now I'm going to come to my function, f's function, and replace all its x's with the square root of x. So I have the square root of x minus 2. Can you simplify that? Nope. So that's your answer. Sometimes you can't simplify, and that's fine. Okay? All right. The next one is where I'm going to take f of x and I'm going to plug it into g of x. Okay, so I'm going to take f of x function and plug it into g of x. So f of x is x minus 2. So I'm going to say g of x minus 2. Okay, I'm going to replace all of g's x's with x minus 2. Well, there's only one x, so I'm going to say the square root of x minus 2. Can I simplify that? Nope. So that's it. Okay, and we're sticking to the simpler ones today. We're going to have another video that's going to make up the level of these, but I want to make sure you understand the process first before we up the ante. Okay, so this one says f of x is 12x and h of x is 6 over x. And I want to find, first I want to find f of h of x. So this is saying that I want to take the f function and I want to plug the h function in. And the h function is 6 over x. So I'm going to take all of f's x's and I'm going to replace them with 6 over x. So now I have 12 times 6 over x. Well, you're going to distribute that 12 and you're going to say 6 times 12, which is going to be 72, and then it's divided by x. Can I reduce that? No. So that would be your answer. All right, next one is where I'm going to take the f function and place it in the h function. So now I'm going to say h of 12x, right? Let's put it over here. I'm going to say h of 12x. So I'm going to take the h function and I'm going to replace its x with 12x. So now I have 6 divided by 12x. Can we reduce that? Yes, we can. Because 6 goes into 6 one time and 6 goes into 12 two times. So my answer is 1 over 2x. Okay? So really it's about plugging each other in and then simplifying what you have once you plug stuff in. Okay, those are really the steps. All right, next one is going to be f of x is equal to 4x plus 3. G of x is equal to x minus 2. I want to find f of g of x. So I want to take the g function and plug it into the f function. So the g function is x minus 2. So I'm finding f of x minus 2. Okay? So I'm going to replace all of f's x's with x minus 2. And remember, use parentheses. So it's going to be 4 times x minus 2 plus 3. Use your simplifying rules. We're going to distribute first. And I get 4x minus 8. Bring down that 3. I can combine negative 8 and positive 3, which will give me a negative 5. Can I combine any more? Nope. So that's your answer. Okay? All right. Next one. This one is where I'm going to take the f function and plug it into the g function. So I'm going to take the f function. So I'm looking for g of 4x plus 3. So all of g's x's will become 4x plus 3. So I've got 4x plus 3 minus 2. Is there anything to distribute over here? No. Is there anything I can clean up inside the parentheses? No. So we're going to drop those parentheses. Now I can combine 3 and 2. Well, 3 minus 2 is going to be 1. And that's your final answer. Okay? All right. Next one is g of x equals x plus, absolute value of x plus 2. And f of x equals 3x plus 6. I want to find where I take f of x and plug it into g. Well, f of x equals 3x plus 6, so I'm going to plug that in. So I'm going to take all of g's x's and replace them with 3x plus 6. I don't need those parentheses, so I'm going to drop them. I can combine the 6 and the 2, which is going to give me the absolute value of 3x plus 8, and that is all I can do. Okay? All right, next one. Next one is where I'm going to take the f function and plug it into the h function. So I'm going to take this function and plug it into this function. So I'm going to have h of 5x plus 2. So I'm going to take all of all of h's x's and replace them with 5x plus 2, and then I have the plus 3. I don't need those parentheses. There's nothing to distribute or clean up, so I'm just going to have 5x plus 2 plus 3. The 2 and the 3 added together will give me 5. And there's nothing else I can combine, so that's my final answer. Okay? All right. I do believe this is the last one. So this one I'm going to take f's function and plug it into g. So I'm going to take the f function and I'm going to replace the x with that. So I'm looking for g of x squared plus 6. So I'm going to have 2 parentheses x squared plus 6 minus 1. I do need to distribute that 2 before I can get rid of the parentheses. Then we'll have 2x squared plus 12 minus 1. I can combine 12 and 1. 12 minus 1 is going to be 11, and that is it, and that is your answer. Okay? All right, so we kept it simple on this one, but we will be doing some more complex problems on the next video, okay? But I want to make sure you understood the process of what to do when you do composite functions, okay? So let me know if you have any questions.